All right, so we're recording. So example 12. Um, and then if you have any questions at the end of class, all right, there were some about the newest set of 5 questions. Hopefully by the time we get through 12 and 13, maybe 1 or 2 of those will become a little bit more obvious. All right, so if you notice on this example here, we have a quotient all the way across, a quotient of variable factors. And so we said we could, turn quotients into products, and that's still not a bad thing to do. So if I do that, that forces me to bring the bottom to the top and put grouping symbols around it, right? So now that it's a product, the second factor looks more complicated. So the outside function is probably going to be blob to the negative first. And then we check, right? What is the inside function? X squared minus 4. Where did the X factor come from? Was it from unpacking that little box with the chain rule? Yeah, because the derivative of that is 2x. We generate the x, we're off by a 2. So we have a correction of a 1/2, and that x gets packaged back up inside. And now part 2, the rule of integration. What's the rule of integration when your inside function is in the numerator to the negative first or the denominator to the first? Natural log, good, of the absolute value of the blob plus c. And that's it, okay? So again, being inside something to the first power can be the hardest one to see. By bringing it to the top, it forces you to put the x squared minus 4 in parentheses. But you could have done it like that as well, right? And realized, oh, my inside function's in the bottom to the first. So anyway, there's that. All right. Now here we got a 5 over x ln of x. If you want, you could do this. You have 2 factors now, but they're both in the denominator. I wouldn't bring the whole group up and say the whole thing is to the negative first power, okay? Because what that does is still keeps them chunked together. And remember, we want a little separation because one of them hopefully is the derivative of the other. So if you are going to bring them to the top, I would bring them to the top individually like this, if you wanted to do that. Now, which one of those factors looks more complicated? The second one? Yeah, the outside functions are the same, blob to the negative first. But the second one has a more interesting inside function, thereby making it a little more complicated. So that could be the outside function. ln of x then could be the inside function. What's the derivative of ln of x? 1 over x. Is that the same as x to the negative first? It is. So are we off by anything? No. So the x to the negative first gets packaged up. And now our inside function is inside blob to the negative first, which is the rule of integration. What's the rule of integration when it's blob to the negative first? Natural log of the absolute value of blob plus c. And oh, by the way, what's the blob? Yeah, very good. Oh, the 5, don't forget the 5. Yes, don't forget the 5. Yeah, the riders in the back of the truck, and we left them outside overnight almost. Yeah, pets, pipes, and people in the back of the truck when it freezes, right? You want to check on those people, pipes, pets. So the natural log was the rule of integration and the inside function. Now notice we need the absolute values on the green part because that's what we introduced. That's the rule of integration. We don't need to add them to the ln of x that was already there because the domain is already implied. Okay. All right. The next one, it's going to kind of play out the same way. I've got a 4. Yeah, so I pull the 1/4 out. I've got an x in the bottom that I could bring to the top again, x to the negative first. And now I can rewrite the natural log of x. Cube root of it squared would be that to the 2/3 power, right? So it's kind of the same idea. Your outside function is going to be blob to the 2/3 instead of blob to the negative first. But your inside function is the same as the previous example. And the derivative is spot on, right? No correction to make. Derivative ln of x is x to the negative first, 1 over x. So the x to the negative first gets packaged back up. 1/4 goes along for the ride. Yeah, I'll put him first this time. Ethan's head was actually blocking the 5 over here from my view the first time. So I'll blame it on Ethan's big head. Okay.
No, it's not. It's a big head. It has to store a lot of information.
That's right. That's right. He works it out as often as he does his quad. So his brain also looks good in a 5-inch inseam. Yeah. 4.5. Oof. All right. So anyway, the rule of integration now is blob to the 2/3. That's the power rule, right? So leave some space, add 1 to get 5/3, 3/5 in front, plus C, and of course the blob is ln of x. Simplifying now, you get 3/20 cube root of, now the natural log of x to the 5th, much like sine of x and cosine of x and all the trig functions, you can write that as the natural log to the 5th power of x. It condenses in the same way that the trig functions do, okay? And then don't forget the plus c. The plus c, remember, has to appear as soon as you take the antiderivative. You can't just kind of do the first part above it and then just put it at the end. It has to appear right away and then all the way through. All right. So far, so good? Yeah, so far, so good, so good so far. Okay. So I think I gave you one of them in the group of 5 where it was in your inside function requires a natural log rule of integration. All right, this one here, I got an E factor in the bottom. That's a constant multiple. So I'm going to pull a 1 over E out, and then I got cosecant of the natural log of x. And once again, I'll bring the x from the bottom to the top. The first factor obviously looks more interesting. So it could be that the outside function is cosecant of blob. Well, guess what the inside function is once again? ln of x. Its derivative is exactly the other factor. No correction necessary. So the 1 over e goes along for the ride, and now we move on to the rule of integration. Cosecant. Whoa, do we know what the antiderivative of cosecant is? We sure do, right? After yesterday, we learned that it is exactly the same as the derivative of cosecant, which was negative cosecant of blob, cotangent of blob, right? And the blob is ln of x. Yeah. But yes, very good. Instead of being multiplied, they're added inside an absolute value with a natural log. Okay. But other than that, it's the same. And then plus c. Right. And again, notice I have dot parentheses with the negative. Of course, when you clean that up, you can bring the negative out in front of the 1 over e. Okay. Bless you. So if you noticed, it looks like for the last 3 problems, our inside function has been the same thing, ln of x. The only thing that's different is the rule of integration itself. Okay. All right, over here, we've got arctangent of x divided by the quantity 1 plus x squared. So if you're into doing what we've been doing, you got arctangent of x in the top. Bring this entire quantity also to the top to the negative first. Which factor looks more complicated? Some of y'all might say arctangent, right? Maybe. Maybe, I don't know. If you think the other one is, right? Maybe you think that blob to the negative first is the outside function. Remember, you would test it. This would have to be the inside function. What's the derivative of 1 plus x squared? It's 2x. Uh-oh. Did we generate the critical arctangent of x part? Not even close, right? Not even close. So that means we chose incorrectly. We're like we're like bowling in the wrong lane. No, that's not going to work. So I guess arctangent is the inside function, but then again, what is it really inside of? Power of 1. Yeah. Blob to the first power. Okay. Now arctangent could be the inside function. What's the derivative of arctangent of x? Hot diggity dog. Isn't that the same as 1 plus x squared to the negative first? Tis. So there's no correction to make. 1 plus x squared to the negative first gets packaged back up, and now we're on to the rule of integration. arctangents inside blob to the first. How do we integrate blob to the first? 1/2 blob squared, right? Power rule plus c. And oh, the blob is arctangent of x. Okay. There you go. Fun, easy, fun, easy. Hopefully it's getting a little bit easier for you. Pattern recognition requires you working a lot of problems. All right, questions on example 12. All right. Well, example 11 I skipped because I actually did an example of each type extra on example 10. And that, I mean, we could do it. Let's backtrack to example 11. X cubed plus 1 is the inside function. The 5 is already in the answer. The derivative of x cubed plus 1 is 3x squared. We're off by a 3. So we have a correction of a third. What is x cubed plus 1 inside of? It's inside of tangent. What's the antiderivative of tangent of blob? Negative natural log of the absolute value of cosine of blob plus c. From yesterday, you forgot about it? Big brain. The brain is just so big, it's hard to like go through all the rooms to find it again.
No, it just leaks. It's like a leaky.
Oh, leaky big brain. All right, so there's that one. Yeah, we should probably do them to review yesterday. There's that one. And what the heck? Go ahead and do the next one by yourself as a warm-up. Bless you, now that we're already warm. I'll pause the recording. Do part B on your own. All right, since nothing needs to be rewritten, you don't have to do a whole rewrite just to bring the 2 out front. You could say that the 2 is already in the answer. Like, hey, 2, why don't you go ahead to the final answer, get there before we do, and save us some seats, right? Like a graduation, which Jackson's family doesn't have to do now, right? Right, e to the negative x could be the inside function. The derivative of e to the negative x, you gotta be careful, is not just e to the negative x. It's e to the negative x times the derivative of negative x, which is -1. A lot of people miss that -1. So we're off by a negative, aren't we? So we have to have a correction of a -1. And now secant is the rule of integration. It's the outside function. The antiderivative of secant is the exact same as the derivative. It's secant blob, tangent blob. Secant blob, tangent blob. And the blob is e to the negative x. The only difference is, again, they are not multiplied. They are added inside absolute values with a natural log in front and then a plus ci. So it's -2. Okay. For some reason, if it were like e to the 5x, most people would know that there's a 5 derivative. But sometimes if it's as innocuous as e to the negative x, you forget the -1 derivative from the exponent. Okay. So there it is. There's the review of those. You should know the antiderivative of all 6 trig functions now. All right. So we did 12 already. Definite integrals. Okay. We're going to do this in 2 ways. Definite integrals, we know it's a definite integral because we see the intervals of integration. So there's an example where the intervals are written above and below the integral instead of like right out in front. But again, as Angeli, I think, asked, where do you put them? They could be either one of those 2 places, right? They're typically not written behind it like that. And they're typically not written like in front of it, like way over here. Right? Because then you'd be like, whoa, what's that? Right? All right, so instead of expanding this all the way out, if it's a product, we could expand it. It would take a little bit of time, but you might as well try the pattern recognition first. Blob cubed could be the inside function. That would be the inside function. What's the derivative of x squared plus 1? 2x. We get the x, boom, we're off by a 2, so we know it's going to work. So we have a 1/2 correction. Now onto the rule of integration. Blob to the third becomes blob to the fourth, which with a 1/4 in front. Now, because it's a definite integral, remember, we don't need the plus c, do we? We just from 0 to 1. Now, again, this is up to you. I like to leave my constant multiples out front when I evaluate it. So I'm going to put 1/8 beefy bracket and then plug in the top minus plug in the bottom. I like to give myself a template. Okay, especially when my antiderivative is more than one term. So I plug in a 1 and I get 1 squared plus 1, that's 2 to the 4th. Minus I plug in the bottom and get 0 plus 1, that's 1 to the 4th. On a free response, you're Brooks and Dunn right there, yeah? Yeah. Boy, howdy, you're done. But on a multiple choice, we keep on keeping on. So 2 to the 4th is 16, 1 to the 4th is 1, so 16 minus 1 is 15. And that simplifies to 15/8. Nothing divides out. So there's the answer. And that remember is the net accumulation then of the integrand from 0 to 1. We don't know if it's the area or not. Now you could do U substitution. So a lot of the times the AP exam will give you a multiple choice question where it says, if the substitution U equals is made, what is the new integral, right? So let's go ahead and do that. We can let U equal x squared plus 1, which is going to be the inside function. The goal is now to change everything that's xy about this to ue, all right? So I always start with, I kind of do it as I go. So instead of x squared plus 1 cubed, it's u cubed. All right, and then you can kind of check that off. Now I need to replace the x and the dx. Because I'm going to need to replace dx, I know I'm going to need the derivative. So the derivative of u with respect to x is 2x, and then multiply both sides by dx if you want to get this. That's called differential form. And again, you're noticing, hey, I can replace the x dx at one time. So if I solve that for x dx, I get du divided by 2 or 1/2 du. That 1/2 there is what we mentally corrected when we checked the derivative. All right, so now I can replace the x dx with a 1/2 du. And we're not quite done. If it's a definite integral, don't forget these intervals of integration, because these are x values from x equals 0 to x equals 1. And I promise there will be a multiple choice answer choice that has everything in the integral replaced with u except the intervals of integration. This is not correct because these are still x values. So don't fall prey to that. So let's go ahead and write it the correct way. It's 1/2 the integral. I'm just going to clean this up, bring the 1/2 out front, u cubed du. And now I need to change those to u values. So how can I figure out what u is when x is 0 and what u is when x is 1? It's that original substitution. So let's try it out. When x is 0, u is 0 squared plus 1, which is 1. And when x is 1, u is 1 squared plus 1, which is 2. Okay. And that could be an answer choice. The 1/2 could still be in front of the integral instead of, or behind it, I should say, with the u cubed. It doesn't have to be out front. But here's the thing. If you are using u sub and it's a definite integral, as long as you change the intervals of integration, you don't have to even substitute it back in. You can leave it entirely in terms of u. Watch this. 1/2. If I integrate u cubed, it's 1/4 u to the 4th, and I'll evaluate that from 1 to 2 now. So that's going to be 1/8. And I plug in a 2 and I get 2 to the 4th, minus I plug in a 1, I get 1 to the 4th, and it still ends up being 15/8. So for a definite integral, if you are using u substitution and you convert everything to u's, including the intervals of integration, you don't have to put it back. If it were an indefinite integral, then you would need to put everything back in terms of x and dx. Okay. So there you go. Kind of fun. Comments, questions, letting it sink in. All right, these last two sections are bears, and not just any type of bears. They're like Kodiak grizzly bears, both of them. Okay. Maybe they're a married couple. I don't know. They get along. Sometimes Kodiak grizzly bears fight each other. 4-3 and 4-4 don't fight each other. They go hand in hand. All right, review the following antiderivatives. Review them. Notice the dx is in the top. You see that? That's a common thing to do. If there is no, if there's nothing in the numerator other than a 1, College Board and mathematicians in general, we're space savers, right? So dx we usually put up there. Remember, it is a factor, but we prefer to see it as a right bookend. So if you ever see dx in the numerator like that, just kick them off to the right side and put a 1 in the numerator. Okay. Now it looks more user friendly, but don't let it really bother you. Now, if we did bring that to the top and we tried to integrate it using pattern recognition, it wouldn't work because the derivative of 1 minus x squared is negative 2x, and there's no x in the top. If there were an x in the top, we would do pattern recognition. And that's where we're like, oh, there must be another way, and there is. We recognize the integrand as the derivative of what? Arc sine. So it's arc sine of x plus c or inverse sine of x plus c, either one. We're reviewing, right? We're reviewing again. All right, letter B. Again, if you were to bring the dx off to the right side and then bring this to the top, to the negative first, if I were writing a multiple choice question, my first thing that I would put is answer choice A. It's the natural log of the absolute value of 1 plus x squared. But that's not it, right? Because what's the derivative of 1 plus x squared? Well, what's the derivative of 1 plus x squared? 2x, right? Is there an x factor anywhere on the outside? No. So it's not a natural log rule of integration. So this is where sometimes bringing it to the top can kind of take you away from recognizing what it's supposed to be, which is arctangent. Yeah, this is arctangent of x plus c or inverse tangent of x plus c. And then this guy that we don't see that often, he's kind of higher maintenance. He is function minus 1 under the radical instead of 1 minus function. And he also has an x out front. This one, remember, is arc secant of the absolute value of x or inverse secant.
So when it doesn't have the absolute value, not the x in front, you put it into the.
Right. It's like the natural log that we have to add the absolute value to include more values because the x in front of the radical could be positive or negative. So those are the only two that I know of where when you take the antiderivative, you add the absolute value around the x for the natural log and the arc secant. Okay. All right. Yeah. Okay. Now these are very, very specific because they're 1 minus x squared or x squared minus 1 or 1 plus x squared. There are other forms and we need to memorize these. I hope you got room in your large brain. I know Ethan does. He just needs a couple of corks for his ears to keep it from slipping out. All right. Maybe so. All right. So if we ever see the integral of 1 or du over the square root of a squared minus u squared, where a is just some constant, okay? This is number minus function under the radical. It's number minus function under the radical. Much like this one was 1 minus x squared, that's number minus function. Number minus function under the radical. This is going to end up being an arc sine, but it's not just arc sine of x. It's arc sine of u over a plus c. Arc sine of u over a plus c. Okay. Now, what this means is whatever you're calling u to be, it's your inside function. The derivative of u has to be the other factor in the problem in the numerator or only off by a constant. Okay. I'll show you why we want to memorize these when we work an example. If you see a squared plus u squared with no radical and they're both added, That looks a lot like arctangent, right? No radical, both positive, number plus function. This is number plus function. Now notice this is arctangent of u over a, but it also has an additional 1 over a in front. 1 over a arctangent of u over a. And then arc secant, if you see u square root of function minus number, well, that looks a lot like this one. X squared minus 1 was function minus number. Then it's going to be arc secant of the absolute value of u over a, and it also has a 1 over a in front. So you don't need to memorize the other three because they're just going to be negative versions of this. But these are 3 rules of integration that you need to memorize because they save a ton of algebra, All right, now notice arc sine is the only one without the 1 over a in front. No 1 over a in front. So they're all u over a. That's what's nice. They're all u over a. Arc secant still has the absolute value around the u instead of the x. And the form fits the other form. Is that a bell? I don't know. Square root of number minus function is arc sine. No radical is arctangent. Function minus number with u out front is arc secant. Okay. Now look at example 15, A and B. These are good. Compare and contrast. Contrast and compare. What's the only difference about the two? Yeah, the first one has a 1 in the numerator. The second one has an x in the numerator. You see that? I'm sorry. So if you want, you could scratch the dx out. So now when you compare them, now the difference is a little more obvious, right? The first one has a 1 on the top and the second one has an x in the top. Well, if you look at the second one, let's do the second one actually first. Life's too short, eat dessert first. Okay, good. So that's x times, if we bring the bottom to the top to the negative 1/2, now you're like, oh, 4 minus x squared could be the inside function. What's its derivative? Negative 2x. Oh, bingo. That's where that x factor came from. We're only off by a negative 2. And so I have to have a correction of the reciprocal, right? Negative 1/2. And now the rule of integration is the power rule. Blob to the negative 1/2 becomes blob to the positive 1/2. And now instead of dividing by 1/2, we'll multiply by its reciprocal 2 plus c. And we get 4 minus x squared. So that ended up being just a simple little power rule, pattern recognition, or u sub, because the x factor was there. Now that does simplify to negative square root of 4 minus x squared plus c. So that difference of an x in the front takes it from this to, wow, it certainly can't be the same thing on part A because the x isn't there. Now, if the x is not there, you're kind of at the end of your integration rope. And you're like, well, what else can I do? I need the x out front to be able to use the power rule. If it's not there, what's hanging at the end of your integration rope? Here's your rope, right? Here's maybe a knot, and then you have some frayed ends right here. Right here above the knot, to save you, you have your inverse trig integrals, okay? Yeah, so let's see. It could be an inverse trig. Which one would it be if it's going to be one? Well, it has a radical in the denominator, so it can't be arctangent. Agreed? Yeah, very good. There's two things that might lead you away from arc secant. There is no x in front, so it's probably not an arc secant, but that's not the actual telltale sign because you'll see later it doesn't have to be there. I'll show you. What's important is that under the radical, since subtraction is not commutative, is it number minus function or function minus number? It's number minus function. So that's going to be an arc sine if it's anything. Arc sine was 1 minus x squared. Now, here's how you could do this easily. This is a squared then, and this is u squared. If you can identify your A and U, you got it made. So what would A be if A squared is 4? 2. And if U squared is X squared, what is U? X, right? Now here's the deal. Don't forget this part. Whatever you're calling U, you still have to check to see if the derivative of U is the other factor in the problem or only off by a constant. What is the derivative of X with respect to X? 1. Are we off by anything? No. So there's no additional correction to make, and there's no rider other than a 1. So we know it's going to go now to arc sine. Now here's the question you ask yourself. Does arc sine have a 1 over A in front for its rule? No, it doesn't. So we go straight to arc sine of U over A is X over 2 plus C. And that's the answer. Okay. Of course, that's the same as arc sine of 1/2 times X, if you like that better, or inverse sine of 1/2 X, if you like that better. Now, I want to show you why it's important to memorize those 3 forms. Let's check. How can I check to make sure this is right? I could take the derivative of it. Let's go ahead and take the derivative of this one here. D dx colon. Educate a college student with the notation. What's the derivative of arc sine of blob? The derivative of arc sine of blob is 1 over the square root of 1 minus blob squared. Yes? But what's the blob? It's 1/2 X. Times the chain rule, the derivative of the blob. What's the derivative of 1/2 X? 1/2. Now, we're saying if this is the correct antiderivative, then this derivative should equal our original integrand of 1 over the square root of 4 minus X squared. It doesn't look anything like that, does it? So here's where the algebra comes in. We're going to be doing the algebra move going forward, which is hard enough. Let's simplify this. This is 1 over the 1/2. I'm going to bring the 2 out in front, and that's 1 minus 1/2 X quantity squared is 1/4 X squared, or X squared divided by 4. Okay. Now, here's what I'm going to do. On the next column, I'm going to say let 2 equal the square root of 4. Are you okay with that? Okay, good. So now in the denominator, this becomes 1 over the square root of 4 times the square root of 1 minus X squared over 4. And when I'm multiplying a radical times a radical, I can put them under the same radical. Like that. I can put them both under the same square root. And now if I distribute, I'll work left to right here. If I distribute under the radical, I get the square root of 4 minus what? X squared. Wow, is that the original integrand? It is. So if you don't want to memorize those 3 forms, what you're going to have to do when you see something like this is you're going to have to factor out a 4, call it the square root of 2, pull it out front, and then you're going to have to write it as 1 minus a quantity squared. You're going to have to do all that algebra in reverse, which is not fun. Okay. It's one thing going forward, simplifying the information that's already there. It's another thing trying to factor something out and put it in a different form. So that saves us from having to do that. Okay. So it's totally worth memorizing, especially when you have the space, and y'all all do have the space. Okay, cool. All right, so again, the existence or non-existence of that X was important. In one case, it was just a power rule. In the other case, it was an arc sine. Got it? All right, letters C and D. It's kind of the same thing. Compare and contrast. The first one has the dx in the top. Not a fan. I'll put a 1 there and I'll put a dx. Let's do the second one first again, because it does have that extra factor of X in the top. So if I leave that x factor there, I'll bring the other piece to the top. Say it's to the negative first. Well, now since there's two variable factors there, this could be the inside function. What's its derivative? 18x. Hey, guess where that x came from? The chain rule. We're off by an 18. We got it. At this point, we know we've got it. So we have a 1/18th correction. Very good. When your inside function is inside something to the negative first, it's the natural log of the absolute value plus c. Yeah. Now, if this were a multiple choice question, they probably wouldn't keep the absolute values around your answer. You can't just get rid of them arbitrarily. But in this case, that was a nice way to open the door. In this case, we can actually get rid of them. Why? Very good. 2 plus 9x squared is already positive for all values of x. You would not be given an answer choice with both of those if this were a multiple choice question, because then they're both correct. But in general, you can't just drop absolute values. Now over here on part C, there is no x in the top. So if you did bring the bottom to the top and you try to do a natural log, you're not checking the derivative first, and it's not going to work. So now you're like, well, I'm at the end of my integration rope. Maybe it's an inverse trig. Well, it's not going to be arc sine or arc secant if it's going to be any one at all, because there's no radical. So it must be, I guess, an arc tangent. Let's see. That would be a squared, and this whole thing would be u squared. So let's identify the a and the u. What would a be? Square root of 2. And what would u be? 3x. Check. Whatever you're calling u, that's your blob. That's your inside function. What would be the derivative of 3x? 3. Do we have a 3 in the top? No, but if we're only off by a constant multiple, is that a big deal? Not at all. So I have to have a 1/3 correction in my answer. There's no rider other than a 1, so I don't have to bring down a 1, but there is a 1/3 correction. And now we go to the arctangent rule. Is there a 1 over a in front of arctangent? Yes, there is. So it's also 1 over the square root of 2 arc or inverse tangent of u over a plus c. U over a. And if you wanted to clean that up, you can call it 1 over 3 square root of 2. You could call it inverse tangent if you want. And that's also the same as 3 over the square root of 2 times x. If you want to write it as a coefficient of a linear term, you could. Compare and contrast. We're still comfortably inside AP curriculum here. These could easily be AP questions. All right, any questions on those two? All right. Let's do the following. Arc secant can be a little bit of a high maintenance thing. All right, let's look at example A. You got 9 over 5. So if I bring the 9 over 5 out front, this might be kind of like what you're doing to start, right? You have two factors in the bottom. So if you want, you could bring them both to the top individually, right? X to the negative first, x squared minus 16 to the negative 1/2. This might be your mental flow chart. Now, here's the deal. The second factor looks more complicated. So maybe x squared minus 16 is your inside function. And maybe it's a power rule integration. But wait, what's the derivative of x squared minus 16? 2x. Is that the same as 2x to the negative first? No. Okay, so you can't just look down here and say, oh, the derivative of x squared is 2x. I get the x here. I'm only off by a 2. That doesn't work that way. It's really an x to the negative first. So you're not just off by a 2. So will it be a power rule? Nope. Okay, so this does not work. You can still bring the 9/5 out front if you want, but if that doesn't work, now you're looking at this, x squared minus 16. You're already at the end of your integration rope, and you're like, it could be an inverse trig. It's not arctangent because it has a radical. It does have an x out front, so it could be arc secant. But the main reason it could be arc secant is because it is function minus number, Ethan, right? Yeah. So this would be u squared, and this would be a squared. So u would be x, and a would be 4. Now let's check. There's a couple of things we have to check. For arc secant, you got to check 2 things. 2 things. Golly, 2 things. You got to check number 1, du. We've been doing that the whole time. And then you got to check out front of the square root. All right, so it doesn't matter the order. Whatever we're calling u, it has to be out front. Is it? It is. So that one checks. And then what would be the derivative of x with respect to x? 1, right? du equals 1 dx. So we're not off by anything, right? So is it an arc secant? It is. It fits the arc secant pattern. You got to check 2 things for arc secant. And we meet both of them. So does arc secant have a 1 over a in front? Yes. So it's a 1/4 arc secant of the absolute value of u, which is x, over a plus c. Yes, Ella. Oh, no, because it's x squared minus a squared. Yeah. Yeah, that's a good question. The 9/5, I just forgot it. Yeah, that's the second time today I forgot someone in the back of my truck. Thank you. Yeah, don't get in the back of my truck, right? There's no seat belts, number 1. Number 2, I'll forget about you. I told you when I lived at the bottom of Rosemary, right? What happened? I did tell y'all. I don't want to say it again. Okay. Someone was in the back of a truck and his angry girlfriend ran through the stop sign. And it's kind of a rough couple of humps there if you run through the stop sign. It bucked him out of the back of the truck and he landed on his head and didn't survive right out in front of my house. Well, he got bucked in front of my house. Luckily, she was still moving forward, so he flew through the air forward. He landed kind of on the other side. He actually landed closer to the backstop by the Sealy playground, but he didn't make it. So anyway, all right, let's do this one here. A dx in the top, not a fan. I like to put a 1 there and put a dx. This one might be an arc secant. This would be u squared. This would be a squared. U would be what? 2x. Well, are you talking about this one still, Mason? Yeah, well, let's wait. I want to identify them first. A squared is 9, so what's a? 3. Yeah. Now we need to check 2 things. We need to check 2 things. Whatever we're calling u needs to be in the front. Is there a 2x in front? No. So this is why it's a little high maintenance. I need to make that a 2x. How do I do that legally? I multiply by 2 over 2. Okay. So this is why arc secant's higher maintenance. Now I have the 2x in front, yes? And now you're like, what's the derivative of 2x? 2. Well, if I don't pull that 2 in the top out front, I can say now I'm not off by anything, right? So however you want to do it. That kind of killed 2 birds with 1 stone. Now I'm not off by anything. So creating what I needed in the front there legally by multiplying by 1, 2 over 2, it kind of fixed both things. So you either go straight to 1 over a, arc secant of the absolute value of u, which is the absolute value of 2x over a plus c. Or if you want to say the 2 that I put in the top can go out front, I have a rider now. And now when I take the derivative, I say, oh, I generate an unwanted 2. Now I have a correction of a half. And now it's arc secant, which is 1 over a inverse secant of u over a. However you do it, the 2 times 1/2 divides out to give you 1. Now, notice that we can actually rewrite this a little bit differently. The absolute value of 2x is the absolute value of 2 times the absolute value of x. So we can actually call that 2/3 times the absolute value of x plus c. In other words, you can bring the 2 out as a factor because it's positive, as long as you bring out the positive version of it. So arc secant is a little high maintenance. Now look at the next one here. I don't know if you'll see one like this in the AP exam, but this one is not going to be a simple power rule because the derivative of e to the 2x is e to the 2x times 2, and there's no e to the 2x in the top. So maybe it's an inverse trig. Can't be arctangent because there's a radical. Is this arc sine maybe or arc secant? Yeah, it has to be. If it's going to be anything, it's got to be arc secant because it's function minus number. But what's missing out in front altogether? Yeah, there's no variable at all in front. Over here we had the variable, we just needed the 2. Over here we don't even have that. So, oh well, we're at the end of our rope. What else are we going to do? Well, if this is u squared and this is a squared, u would be what? Well, off to the side here, e to the 2x is the same as e to the x squared. Okay. Yeah. So it's just e to the x, and a squared is 1, so a is 1. Now, look, we can create what we need. We need whatever we're calling u to be in the front. So yeah, I can put an e to the x there. Legally, as long as I do what in the top? Put an e to the x as well. Now, I also need the derivative of what I'm calling u to be in the top. We're only off by a constant. What's the derivative of e to the x? E to the x. Oh my gosh. This is like, I think over here we didn't kill 2 birds with 1 stone when we put 2 over 2. We just maimed 2 birds with 1 stone. Here we actually, we killed them. Yeah, yeah. So it is actually an arc secant, and we're not off by anything. Wow. So arc secant does have a 1 over a in front, so I'll put 1 over 1 arc secant of u over a, the absolute value of e to the x, over 1 plus c. Free response, you're getting full credit there. Multiple choice, though, that won't be an answer choice. Do we need to keep the absolute values around the e to the x? No, because e to the x is always positive. So you can just put arc secant of e to the x with parentheses plus c. Of course, on a free response, you can keep them there, but a multiple choice answer won't have them. All right, will you see arc secant on the AP exam? I don't know. If you do, you're ready for him. He's a little high maintenance. We got to check 2 things. All right. Now, that's the end of the AB integration techniques, but there still are some strategies that we need to look at. Okay. Strategies. So that's what we start with example 17. And we've seen some strategies. If you look at this one here, if you were to bring this thing, and you could kind of do this in your head, if you were to bring that to the top and say it's all to the negative 1/2 power, that could be your outside function. And then your inside function would be 4 minus x squared. You would check then, what's the derivative of 4 minus x squared? Negative 2x. Ooh, I get the x right there, yeah? So it could be a power rule, except that plus 2 is ruining it. The plus 2 is ruining it from becoming a power rule. So I'm like, you stupid 2, if you weren't here, I could do a power rule. And the 2 is saying stupid right back to the x. You know why? Because the 2 is saying, well, stupid x, if you weren't there at all, and it was just me in the house, now I could be an arc sine, right? See that? Split it up. Good. When 2 children fight, you just send them each to their own room. So that's the strategy here. We're going to split up the numerator. So we're going to get the integral of x over the square root of 4 minus x squared plus 2 over the square root of 4 minus x squared dx, and now parentheses. You don't have to give them each their own integral unless you want. They're going to both need their own dx. So now if we simplified that, I'm going to write the first one as x times 4 minus x squared to the negative 1/2, plus the second one I'm going to write as 1 times 1 over 4 minus x squared. That's a strategy. Split up your numerator. Okay, let's do these now. The first one, I'm only off by a -2, yes? So I have a correction of a -1/2. And now the x gets packaged back up. And the rule of integration is blob to the +1/2 times 2. This is your rule coefficient. And we don't need to put the plus c here. We could just wait till we're done with the second one. So that's a power rule. The second one, the 2 goes along for the ride. This is a squared, so a is 2. This is u squared, so u is x. What's the derivative of x? 1. Are we off by anything? No. So it goes straight to the arc sine. Does arc sine have a 1/a in front? No, arc sine is the only one without a 1/a. There's no correction to make. There's a rider of 2. So we go straight to arc sine of u/a, which is x/2 plus c. And there you go. Simplify it if you want. So that's a good strategy. Splitting up the terms in the numerator. Divide and conquer. And it's time to go? Yep. All right. So will we be able to finish on Monday? I say hopefully. I say hopefully. All right. Y'all have a good weekend.